During this lesson, we will be looking at the flight director system. We will see how information is displayed to the pilots, the components and inputs required for the system to work, and then look at the typical dual flight director system. The flight director system was originally designed to reduce a pilot's workload during the busy approach phase. To do this, the original artificial horizon was replaced by an attitude director indicator, ADI, which could display pitch and roll attitude commands provided by the flight director system. This helped reduce the number of instruments a pilot needed to scan during the approach. The flight director system uses one of two ways to display the information, either using twin bars forming crosshairs or a V-bar. Both demand pitch and/or roll inputs from either the pilot or the autopilot. With the twin bars, the vertical pointer displays roll commands, and the horizontal one displays pitch commands. The V-pointer moves as a whole unit to command roll and/or pitch inputs. A fly-up command is displayed like this. Fly down is displayed like this. Fly up and left looks like this. And when commands have been satisfied, the pointers are centralized like this. The attitude director indicators are being replaced by electronic primary flight displays, which are part of the modern electronic flight instrument system. They not only include the above indications, but also can display much more information. This includes indicated airspeed, pressure altitude, vertical speed tapes, and sometimes part of the navigation display. The flight mode annunciator is at the top of the display and indicates the modes and status of the flight director, autopilot, and autothrottle systems. The horizontal situation indicator is a gyromagnetic compass display which has added navigation information. On the mode control panel, we have a heading select switch which, when selected, allows the heading bug selector to select the heading for the flight director to follow. On some older aeroplanes, the heading bug selector is on the HSI. Also on the mode control panel is a course selector which allows a course to be selected for the flight director to follow when in VOR lock, which we will look at in the next lesson on flight director modes of operation. We have already discussed the displays used by the flight director system. Now let's look at the components that provide the information to those displays. The heart of the system is the flight director computer, which gathers and processes the information. Between the computer and the displays is an amplifier or symbol generator. The amplifier will amplify the signals so they can drive motors in the displays. This is used on older systems. The symbol generator generates symbols which are then displayed on the primary flight or navigation displays. In older aeroplanes, there are analog inputs from the air data computer and vertical gyro. The signals are converted via a digital converter into a digital output so that modern displays and autopilots can be used. In more modern aeroplanes, the vertical gyro is replaced by an inertial navigation system or inertial reference system, as they have much more sensitive gyros. The flight director system also requires inputs from the VOR ILS systems to enable it to display the aeroplane's position in relation to these navigation aids. The flight director also needs to know the aeroplane's height above ground, and therefore has an input from the radio altimeter. The flight director system needs to know heading information, which in more modern aeroplanes is supplied by the inertial navigation or inertial reference system units, but in older aeroplanes was supplied by a gyro compass. In addition, we require a means of inputting information into the flight director system, and for that we have mode controllers, or a mode control panel. We will look at this in more detail during the next lesson on flight director modes of operation. To be able to operate the system successfully, crews need to know which mode the flight director is operating in, and so we have flight mode annunciators, normally displayed on the top of the primary flight display, or separate mode annunciators on the pilot's panels for analog displays. We will take a closer look at the flight mode annunciators. These are vital to indicate to pilots the modes of operation of the flight directors and autopilot in roll and pitch, as well as the autothrottle mode and status of the autopilot, including automatic landing capacity. On older generation aeroplanes, the indicators turn amber when the system is armed, and green when the mode has been captured. With an aeroplane equipped with a primary flight display, armed modes are displayed in white and shown on the second line. When the system has captured the mode selected, it changes to green, moves to the top line of the display, and for 10 seconds has a green box around it. Most modern aeroplanes are fitted with at least a dual flight director system. This allows for redundancy. The systems are also compared by a flight director comparator. The flight director comparator compares the output from both flight directors, and if a difference is found, the flight director bars will be removed, and the crew will then have to rely on raw data. When both flight directors are being used without the autopilot, then the one that was selected first becomes the master. This is indicated on the mode control panel. The flight director modes selected are controlled by the master flight director and are displayed on both primary flight display flight mode annunciators. Having two flight director systems also means if one system should fail, then as long as the display equipment is serviceable, both can display the remaining flight director. This is normally achieved automatically in modern generation aeroplanes and by a switch selection in older aeroplanes. Flight director system failure indications are normally shown by flags primarily on the attitude director indicator or the primary flight display. Failures of the flight director computer, instrument amplifier, or the attitude direction indicator itself are displayed as an attitude or flight director flag. There are also failures of glide slope information, which are indicated by a red glide slope flag. Poor reception or loss of navigation information can be displayed in many ways. During this lesson, you have learned about the different types of displays and the main components of a flight director system.